I'm working my way through the feature set of the Nengi Beta 3 2D shooter with lag compensation. This video is about the last feature added to this demo, which was the concealment of packet loss. But first, it helps to have watched all the other videos on this first. We've got to get a little bit of a history to understand what exactly this is fixing in the scheme of a network game. At first, we had a problem in games where laggy players couldn't play the game. They would skip around, or they would not be able to move the same speed as the other players. We compensated that by introducing delta time, variable length frames for players. We made it deterministic, and we made it so they can move on the client and the server in the same way. But a side effect comes from this. If a player has very bad packet loss, they will send all of their input to the server in chunks. Packet loss in TCP and WebSockets is corrected automatically by the protocol itself. What happens is protocol packets are ordered in TCP. They have little stamps on them, and the recipient of them has to acknowledge that it's received a packet. That doesn't mean packet loss doesn't exist in the internet. It does exist. It just means the protocol is trying to cover it up. So when a packet gets lost, this protocol figures out that the packet's lost. Probably because we got packets 1, 2, and then 4, and it's like, well, what happened to 3? When the packet's lost, it asks for it again, and it stalls all packets that followed it. 4, 5, 6, 7, 8 may have come, but it won't release them. Not till the missing packet comes. When the missing packet shows up, then all the packets get to play in order, kind of rapidly. This is kind of lag we've probably all seen. Something kind of stops for a bit, and then it stutters and catches up. Packet loss is a real pain. It's great that TCP fixes it, quote unquote, but it still manifests as lag. When we write all these kind of lag compensation techniques, as has been shown in this demo so far, we have thus enabled a lower range of computers with more connection problems to still have kind of a fair shot at the game. But we end up with one final problem, which is that to everybody else, they look very laggy and skippy. They can play, they can move the right speed, they can shoot, their shots are compensated, all the fancy stuff. But, we get nothing from them for a second, and then we get 40 packets from them, and then we get nothing from them, and they can't be shot at, they're a slideshow. So, to fix this, a tedious and not too special technique is used. It's all visible here in player character. And the notion is that we took the same kind of update logic that we had prior to that problem of just moving the player, and we gave the player, instead of one position, we gave them 2 positions. We run their normal movement data, and instead of moving their x and y, we now move a variable called allowed x and allowed y. What is the allowed x and allowed y? Well, it conceptually represents where they would have moved to, just as before, except because we're trying to fix this lagginess, we no longer actually move their player, at least in other people's eyes, to that position. Instead, we maintain 2 positions, one of their body, of where we're going to show it for everybody else, and a second of this allowed position. The code is, well, you can read it all here in player character. I can't explain it line per line because it's too long and it's too tedious. But essentially, we have regular movement code, very straightforward movement code. And then we, at the very end of it, instead of moving the player, we create this allowed x, allowed y, and we push it into a queue of nodes, or a path of nodes. Kind of the way AI works, where it moves along a path of multiple nodes. We create a path of multiple movement nodes for the player. Then, in the server update loop, we, once per tick on the server, we move the player's body along the path to catch up to its allowed position. When the player isn't lagging, nothing really special happens here. The allowed position and their actual position are very close or the same. When the player does suffer some packet loss or some lag, these two begin to deviate. The allowed position slides off. and away and behind, or rather, sorry, the allowed position slides ahead and their body remains behind. Because of this, this update logic can't just move the allowed player at the same constant speed all the time, otherwise it would literally never catch up. You'd get behind a little bit and you'd stay that behind forever. So we've got some fancy math in here that tries to basically modify the movement speed at which we're allowed to follow through those paths to catch up. There's also a hard-coded limit over here, rubber banding logic. In this particular demo, it's set to 1200 units. If we ever make it that far away, we reset both the X and Y in the allowed position, make them the same, clear the path. This creates a strong rubber banding for the player. Let me see if I can show it to you by connecting to the New York server and running a whole lot of packet loss. So let me reconnect, make sure. Here I am moving around happily at whatever my natural latency is, blasting this other character. I'm going to turn on a little bit of lag, 250 milliseconds. This shouldn't create any problem either. We're well within the bounds of connection that, you know, this Nengi demo is trying to compensate for. Now let's do something drastic, 10% packet loss. Now, if you're unfamiliar with packet loss, let me tell you 10% is really bad. You're gonna feel 2 or 3% and hate it. 4% is gonna get bad. Any higher than that, you're arguably not really connected to things. In any case, playing with 10%. What do we see? We see the first bit of sweat from Nengi. Or I shouldn't say Nengi, because really all this compensation code is part of this game, not part of Nengi. We see a first bit of sweat, like it's not quite, there's something a little staggery about it. Let's turn it up to 20%, which is insane, mind you, insane. And let's reconnect. Let's see if I even can reconnect. Okay, it made it. Move around. See, my shots have totally broken. They're extremely laggy. And I get a little bit of stuttering. Oh, there, finally a teeny bit of rubber banding. I don't know, I don't consider this a teeny bit. It's not showing too dramatically, but it, you know, this game's just got kind of this cheesy grid in the background. There's not a whole lot going on visually. This is 250 milliseconds added latency on top of connecting from US West to US East and 20% packet loss. I could guarantee you if this was an actual game of actual stuff happening, we'd be pissed right now. But there you get to see, you know, it's suffering a bit. You know, it's entirely the intention of this demo in Nengi that within the realms of realistic connections that exist, that we've essentially created the antidote for lag. Is that true? No. There's always some laggier computer, laggier machine, and as you make games for players that are very accommodating, you know, people come play your game because they can't play some of the other games, so you really do, you'll always find somebody who can still experience lag in the game. Potentially a lot. In any case, that's the final and, yeah, the final lag compensation technique in this demo. I hope if you've watched the whole series, it has at least answered some of the questions. Thanks for watching and good luck programming.